Hey there, welcome back everybody. In this section we're going to continue to work with equations and solve some equations, but this time we're going to use them to solve some word problems. We'll develop a simple strategy for solving word problems and then look through a few examples. So let's take a look. Before we take a look at any examples, let's look at a general strategy and some tips for solving word problems. First of all, and by far the most important, let's read the problem carefully. Lots of times people come to me with questions about a word problem, and the real hang-up is just that they don't understand what the problem's describing. You might need to read that problem several times and think carefully about it. Don't try and write an equation until you really understand the problem. Second of all, we want to really be sure that we identify what the unknown in the problem is. That is to say, what are we actually trying to find? Again, that seems obvious, but that's kind of easy to overlook. X is sort of the default variable that everybody uses, and that's okay. But if you use some letter that represents what you're trying to find, it kind of helps you contextualize the problem and makes it a little bit more intuitive. Next, we need to identify our parameters. That is to say, what are our limitations or what information are we given about the problem? And again, you don't have to get that directly into an equation, just make a note of it. Third of all, use the tips that you're given. There's always kind of word clues as to what you're trying to do. So things like difference, which means subtraction, total, which means addition, sum, addition, product means multiply, and then even casual words that you come across like of or per. Per, for example, almost always means division. And so when you pick up on those things, they can often be real useful for writing your equation. And finally, once you solve that equation, you should be able to check your results and see if your answer doesn't work. And sometimes just the act of checking will help you realize a mistake that you've made. So let's take a look at a couple of simple examples, and then we'll get a little bit more complex. When a number is multiplied by 3, the result is 10 less than half that number. So what is the number? Well, first of all, let's take a look at our process here. Number one, let's read that problem carefully. Make sure that we understand exactly what we're being told. And then step two, let's assign a variable. When a number is multiplied by 3, okay, let's give that a name. Let's call our number n. We could use x, but n will represent number. We're going to do what now? We're going to multiply that number by 3, okay? So we're going to multiply that number by 3. The result. Now, what does that tell you? It's easy to just gloss over that word, but result. Usually in math, if you're trying to find a result, you're trying to figure out what it equals. So we can say that 3 times our number, when our number is multiplied by 3, we get a result, or that must equal 10 less. And now notice these words that we're given here. We're given words like less. Well, less isn't listed here, but less is definitely telling you that we're going to use the operation of subtraction. So we're kind of on step 4 here. We're using keywords to write that equation. So our result is 10 less than half the number. Now be careful because it's tempting to say 10 less, but that would mean that we're starting with 10 and decreasing it by our number. Instead, we are going to take something minus 10. Well, it's 10 less than what? 10 less than half the number. Half the number would be 1/2 our number. So that's half our number, and 1/2 n minus 10 is 10 less than half our number. So let's just read that one more time. When a number is multiplied by 3, 3n, the result, there's our equal sign, is 10 less than half the number minus 10. There's our equation. So we should be able to solve that now and see what our number is. Okay, as we saw in our earlier work, we've got a fraction in there, so let's get rid of that fraction and multiply both sides of this equation by 2 to get rid of those fractions right off the bat. And when we do that, the left side becomes 6n, the right side becomes just n, and negative 10 times 2 becomes 20. So 6n equals n minus 20. Let's put these n's together, minus n, and we now have 5n equals negative 20. Now if we divide both sides by 5, we get a number that is negative 4. Now let's see if that actually works. Let's read the problem again and actually check this. When a number is multiplied by 3, so if we take 3 times negative 4, of course we get negative 12. The result, that should be equal to 10 less than half our number. Well, if our number is negative 4, then half of our number would be negative 2, and 10 less than that would be negative 12. So yes, it works out just fine. We got our solution. Okay, why don't you take a minute and see if you can solve this one. Two consecutive integers are added, and then that total is doubled. The result is 58. What are the numbers? Now you could probably do a little trial and error and figure this out, and there's value in that, but I'd like to see if you can do this by writing an equation that describes that situation. Go ahead and solve this. Pause the video and unpause when you're ready to see a solution. Okay, two consecutive integers. Well, we're not trying to solve for two, because if we know one of them, we'll automatically know the other. If we can just find one of those integers, then our other one must be the one after that. So we're going to let I be our first integer. Okay, now what does the one after that have to be? If we knew our first integer was 12, the next one must be 13. If we knew our first integer was 11, then we knew our next integer must be 12. So if I is our first integer, then I plus 1, that must be our second integer. And that's sort of the key to the problem. Now, here's our two consecutive integers, I and I plus 1. What are we going to do with those? We're going to add those. So I is our first one, plus our second one, I plus 1. Two consecutive integers are added, and that total is going to be doubled. So we're going to have to take that total, I'm going to use a set of brackets, and multiply that by 2. So we're adding them together, and we're doubling it, and the result must be 58. What are the numbers? Well, we now have an equation to solve. 2 times I plus 1 is equal to 58. Okay, let's combine some like terms inside the brackets here. We have 2 times I plus 1, that's really 2I plus 1 inside the bracket, and that equals 58. Now we could distribute in the 2, or we could just divide it off. And if we do that, we get 2I plus 1 is equal to 29. We can subtract 1 from both sides, and we get 2I is equal to 28, and divide that by 2, and apparently then I is equal to 14. So our integer is 14, and our second integer must be 15. Those are our two consecutive integers. Now let's see if that's true. If we add these two together, we get 29, and then double that, we would get 58. And so that works out. We found our solution. Hopefully you got that, but if not, you might want to rewind the video and pause, make sure you understand where you made a mistake there. Let's take a look at another one. 4 consecutive odd integers are added and their total is halved. The result is 100. What are the 4 integers? Well, this is similar to a problem we did just a minute ago, but this time we have 4 consecutive odd integers. So that could be like 3, 5, 7, and 9, or 23, 25, 27, 29, 4 consecutive odd integers. Well, again, there's 4 of them in a row, but we don't need to find all 4 of them. We really just need to find the first one, and the other 3 will come into play. If we knew the first one was 7, then we'd know the next ones are 9, 11, and 13. So let's let our unknown variable, n, be the first odd integer. Now here's the key. What would the next odd integer be? Well, it's not going to be the next number n plus 1 like we did with I a little while ago. It's actually going to be 2 beyond that. If 7 was our first number, then 9 would be the next one, 2 beyond that. N plus 2 would have to be our second odd integer in the sequence. And then 2 beyond that would be n plus 4. And of course, the last in this series would be n plus 6. That would be 2 beyond that. Okay, so here's our 4 consecutive odd integers, n, n plus 2, n plus 4, and n plus 6. Now it's tempting to say, well, wait a minute, we're adding even numbers on. Aren't these consecutive even integers? No, because even the odds are spaced 2 integers apart. So these 4 consecutive odd integers are added and their total is halved. So let's add them up first. We have n plus 2 and n plus 4 and n plus 6. And if we add those all up and then it says our sum is halved, the result, that is say it must equal 100. There's our equation to solve. The 4 are added together, their result is halved, and we end up with 100. Let's figure out what they are. Well, as always, we've got a big old fraction here, so let's multiply both sides of this equation by 2. On the left side, that cancels off, and on the right side, we end up with 200. Now we can combine some steps here. Let's put some like terms together. We've got n plus 2 plus n plus 4 plus n plus 6. That's a grand total of 4n. And 2 plus 4 plus 6, that's a total of 12. 4n plus 12 is equal to 100 times 2, that's 200. And we can solve that pretty quickly. We'll subtract 12 from both sides. And if we do that, we end up with 4n is equal to 188. And if we divide both sides there by 4, we get 47. Now remember, that was the first in our sequence. So the first number in our sequence is 47. The next consecutive odd would be 49. After that, 51. And after that one, we'd have 53. And you can check that easily enough. I won't even write it out here. But if we add these 4 together, we get 200. And when we have that, we would get 100. There's our solution. All right, here's a tricky one. I'd like you to try this one before we work through it. There exists a fraction whose numerator is 4 less than the denominator. Focus on that. How do you write a fraction whose numerator is 4 less than the denominator? If you can do that, the problem works out pretty nicely. If 1 is added to the numerator but subtracted from the denominator, you end up with the fraction 3/4. So what is your original fraction? See if you can do that. Unpause when you're ready to see that solution. Okay, so there exists a fraction whose numerator is 4 less than the denominator. So we know that we have a fraction, and the numerator is 4 less than the denominator. So let's let d be our denominator. If d is our denominator, the numerator is 4 less than the denominator. That must be d minus 4. So there's our original fraction. Whatever the denominator minus 4 is, that's our numerator over the denominator. Now what we're going to do is we're going to add 1 to the numerator but subtract it from the denominator. So if we take our fraction, which we now know is d minus 4 over d, we're going to add 1 to the numerator, but we're going to subtract it from the denominator, and we get a result of 3/4. Okay, there's the equation that we need to solve. So let's go about that. We can clean this up a little bit. In the numerator, we have d minus 4 plus 1. That's really just d minus 3. And in the denominator, we have d minus 1, and that equals 3/4. All right. Now, how are we going to solve this? We could multiply both sides by the common denominator of 4 times d minus 1, or we can cross multiply. We haven't done that a lot. But remember, it is certainly true when you have two equal fractions or a proportion like this that the cross products must be equal. So in one direction we get 3 times d minus 1, and that has to be equal to the product in the other direction. That's 4 times d minus 3. Now that's easily solved, and so if we distribute, we get 3d minus 3 equals 4d minus 12. So let's subtract 3d from both sides to get the d's together, and at the same time we'll add 12 to get the constants together, and we end up with 9 equals d. So we just found our denominator. The d value here is 9, and so our fraction has a denominator of 9, but remember the numerator was 4 less than that, so our fraction must be 5/9. Now to check that, we were told that if we add 1 to the numerator but subtract it from the denominator, we get 3/4. So that's our answer, but if we check this, Let's add 1 to the numerator and subtract 1 from the denominator. That gives us 6 over 8, which sure enough is equal to 3/4. And so we got our solution here. I hope you got that. If not, make sure that you see where your error is. You'll be doing problems similar to that in the work for today. Okay, let's take a look at 2 more problems here before we wrap this up. You might recall that anytime we work with a percent problem, there's 3 parts to the problem. There's the amount, there's a base, and there's a rate. The base is typically the number that we're starting with. The rate is our percentage that we multiply by the base, and that result gives us our amount. The price of a server including 6.5% sales tax and a $54.25 shipping fee is $28.75.44. What was the original price? Well, again, focusing on the first step, which is to understand the problem, we know here that we're buying a server, we're paying tax on it, we're also paying shipping, and that those 3 add up to our total. Now, which one of those are we actually trying to find? What was the original price of the server? So let's let our server be S. That's our variable. Now the tax isn't a separate variable because it depends on the server. So the tax is going to be 6.5% of S. But we know that 6.5% of S is mathematically just the same as 0.065 S. Now to that we're going to add on our shipping costs, but the good news is we know our shipping cost. That was $54.25. And the total there turns out to be $28.75.44. And just like that, we've got ourselves an equation. The server plus the tax, which is 6.5% times the server's price, plus the shipping has to equal our total of $28.75.44. Let's solve this. First of all, the shipping plus the tax can get added together. Remember, S is like having one S. So we can combine those and call this 1.065 times our server price. And then we will subtract off the $54.25 from both sides. That'll tell us what the price of the server and tax was without the shipping on. And so 1.065S is equal to 2821.19. And we're home free from there. We can divide by 1.065. Dividing there, of course, because 1.065 was multiplied by S. That cancels to leave us with a server price of $26.49 even. Now, that answers the question. That was the price of our server, but let's just check this. How much was tax? Tax is 6.5% of that, so tax would be equal to 0.065 times 26.49. And that turns out to be 172.19. And of course our shipping was told to us. Our shipping was 54.25. So now we should be able to add up those 3 and get our total price. And if we do that, we get 28.75.44, and that is exactly what we were after. So our server cost $26.49. Last problem here today, a combined value problem. Suppose 480 acres of land are purchased for a total price of $2.32 million. Some of that land is dry, can be developed right away, but some of it is swampy. Dry land is worth $5,200 per acre, but the swampy land is only worth $3,200 per acre. Then how many acres of each are there in this entire tract? Well, first of all, let's just kind of visualize what this looks like with a little picture here. We've got some nice land and we've got some swamp. Now, even though there's 2 unknowns there, if we knew one, we'd automatically be able to find the other. Because if we knew how many acres of nice land there were, we could subtract to find out how many acres of swamp. So if we know that we've got n acres of nice land, then the swamp has to be all the rest of it. That is to say, the full 140 acres minus the amount that was nice land. We also know that the nice land was worth $5,200 per acre, while the swamp was only worth $3,200 per acre. So we know what the total value is though. So the nice land, we have n acres at 5,200 per acre. So we can say that the total value of the nice land is 5,200 times however many of those acres there are. Now the swampland has value too, but the price is only 3,200 per acre, and the number of acres is everything that's not nice. That is to say 480 minus the number of nice acres. And we know that that total is 2.32 million, or in other words, $2,320,000. And there's a nice harmless little equation to solve. Let's pop through that. 5,200 times n, that's 5,200 n. 3,200 distributing around times 480 is 1,536,000. Minus 3,200 n. And that's going to equal 2,320,000. Okay, we can subtract off that 1,536,000 here. And at the same time, we combine 5,200n minus 3,200n, and that's going to leave us with 2,000n being equal to 784,000. And then, of course, for home free, we can divide that by 2,000 and get a result for n. N turns out to be 392. Good thing we got a positive number here. That's the only thing that really made sense. So we can basically answer the question. There must be 392 acres of nice land, and 480 minus 392 leaves 88 acres of swampland. That does add up to 480. Now, again, pretty easy problem to check. We'll just do this one directly on our calculator. If we have 392 acres at 5,200 per acre, that land is worth $2,038,400, plus we have another 88 acres at 3,200 per acre, and if we add that up, we get $2,320,000. There's our $2.32 million. Worked out just fine. All right, so that wraps up this topic. I'm going to give you a little bit of practice now. Blackboard will have an assignment for you. Go ahead and do that, and as always, reach out if you have any questions. But remember the general tips for solving these word problems. Make sure that you understand the problem and read that carefully. Don't even try and write an equation until you really understand what's going on. Make sure that you clearly identify what your known is. What's the one number that would tell you the answer to everything else within the problem. Make sure that you really understand what information you're given, what your parameters are. Try and figure out what that number x, or what your variable, really depends on. Of course, always watch for keywords. Sometimes it's just one word in a word problem that'll reveal everything that you need to solve it. And of course, make sure to check your answer when you're done. So, let me know if there's any problems that I can help you with. Make sure to use the resources that are available to you, and we'll see you in the next lesson.